Hello guys, and welcome to this video. In today's video, I'm going to provide the solution to the question we had before was here, and it's actually a GCE Waec question, and it's actually from the theory aspect. So in the question, we are told that a town J is 20 kilometers from a lorry station, and that station is K on a bearing of 065 degrees. Then another town T is 8 kilometers from K on a bearing of 155 degrees. We are asked to calculate to the nearest kilometer the distance of T from J. And Roman figure 2, we have to calculate to the nearest degree the bearing of T from J as well. Now it is actually simple. The question has two parts. We have part A and part B, but we're going to first work on part A, and after that we'll work on part B. Now it's important to note that this question is from a topic in mathematics known as bearing, and for every question under bearing we take note of one single word. That is, there is one word that tells us where or how to start answering the question, and that word is the word from. So in any question on bearing, try to look for the word from. The word from will tell you where to start answering the question from. So in the question we are told that a town J, that town is town J, and that town J is 20 kilometers from a lorry station. Now you are seeing the word from there, so it means that I'm going to start my construction from the lorry station, which is K. Are we clear? So I'm going to have that point K, which is this, the lorry station. So this is point K. Right? So they said this point K, the distance from the lorry station to that town is 20 kilometers on a bearing of 065 degrees. Now be taking note of the bearing. If this is 065 degrees, we know that in a bearing we have 4 quadrants, and each quadrant is 90 degrees. So for this quadrant is 90, here is 90, here is 90, here is 90. You will agree with me that this 65 degree will be under the first quadrant, which is 90 degrees. So if I draw something of this sort, 65 degrees, I'm going to put the same bearing, 3-figure bearing, because it's from the question. So I'm having 065 degree, and the point that it is going to is point J, which is that town. So I'm going to have that point J in this location. So this is point J. Now notice that the question didn't stop there. The question said, and another town, which is town T, is 8 kilometers. Sorry, the distance from J to K is 20 kilometers. I didn't indicate that. So the distance from this town K to J is 20 kilometers. Right? Okay. So they said another town T is 8 kilometers from K. That means I'm going to construct this town T from town K on a bearing of 155 degrees. You all will agree with me that for 155 degrees is going to be in the second quadrant. So if this is 90, I'm going to find 155 here. So it's going to be somewhere in this location. But I'm going to take note of something. They said the distance is 8 kilometers, right? So it's going to be a bit shorter. The line I'm going to draw is going to be a bit shorter than these 20 kilometers here, right? So I'm going to have something of this sort. So let's say this is my 8 kilometers from the question, because practically this line is supposed to be shorter than 20. Let me make it more shorter. It's supposed to be shorter than 20 kilometers. So something of this sort. So I have another town here, and that town is going to be town T. Notice I'm using capital letters for all of this. So what I'm going to do basically is to join these two lines together to connect these 2 points. So if I connect this point down to this point, I'm going to have something of this form. Are you seeing that now? Now in mathematics we note something. If you are given a triangle of this form, and you are told that here is capital letter A, capital letter B, and C. These capital letters represent the angles. So this is angle A, angle B, and angle C. So where the angle is facing represent the side of the angle. So if this is an angle A, it's facing below. That means here is going to be side A. This is angle B. Here is going to be side B. So where the angle is facing is going to be the small side of the angle. And this angle C, so it's facing this way. So I have small letter C here. So all these small letters represent the side, while the capital letters represent the angle. So in this form now, this capital letter K is facing this form, facing this way. So here is going to be my small letter K, and this capital letter T, so it's facing here. So this part here should be my small letter T, and this capital letter J is facing below here, right? That means here should be my small letter J. Right, that's one thing we'll take note of. Now let's continue answering the question. We are told to find to the nearest kilometer the distance of T from J, that is this distance. Basically, we're looking for K. Right? Now, we're going to do some analyzation here in this triangle. If this is an angle of 65 degrees, which is the bearing of J from K, right? And they said the bearing of T from K is 155. So basically, from here down to this line here, from this line, from this north down to this line touching T should be 155 degrees. Is that not? So basically, if this is 65, subtract from 90, you get 25 here, right? And if you add 65 to 25, you have 90. So what do you need to add to 90 to make 155? That should be 65. So if you add 65 plus 25 plus 65, it should give you 155, which is the bearing of T from K in the question, right? T from K. Alright, so basically if I add these two angles here, 65 plus 25 should give me 90 degrees. So basically I'm dealing with a right angle triangle in this question, right? How do I know it's a right angle triangle? Whatever angle that gives me an angle of 90 degree here is the right angle triangle. Now what do you notice in the right angle triangle? Whatever the 90 degree, that is the right angle is facing, is the hypotenuse, right? So it means that this is the angle 90, it's facing this place. That means this K is my hypotenuse. So remember, I'm looking for the value of K. So I'm going to use the Pythagorean theorem, which says that K square, which is the hypotenuse square, is going to be the opposite square, T square plus K square, plus a J square, right? Using the Pythagorean theorem. So what is the value of small k here? This is supposed to be small k. So the value of small k is what I don't know. So I'm having k squared is equal to the value of my t squared. You know, t is 20. This is 20. So I'm having 20 squared plus my j squared is supposed to be 8. So I'm having 8 squared. So k squared will be, squared is you have 400. Squared is you have 64. So k squared should be 464. And when you root both sides, square root both sides, you have that k will be equal to the square root of 464. Therefore k, now we are asked to round up to the nearest kilometer. K should be approximately 22 kilometers. So now we have the value of this side. We have the value of this side to be 22 kilometers. So we've answered the first part. So for the second part, we are told to calculate to the nearest degree the bearing of T from J. So basically we are going to start from J, because the question said from, right? So I'm starting my construction from J and I'm moving in a clockwise direction. So from this point J, I'm going to start moving until I touch this line going to T, right? So I'm going to add the angle here plus the angle here plus the small angle here. right? So basically I have to find the angle here, and if here is 25, that means outside here too is 25 degrees. So I have to find the angle here, and to find the angle there, we're going to use the sine rule. To use the sine rule, or the question should be, when should I use the sine rule? You know, when you have a given angle in a triangle, which is this one, and you want to use that angle to find another angle in a triangle, we use the sine rule. So basically the sine rule states that the sine rule states that small letter a over sine a is equal to b over sine b is equal to c over sine c. But notice that I don't have a, b, c's. I only have j, k, and t, right? So it should be k over sine k is equal to t over sine t is equal to j over sine j. So basically I'm not going to use this capital letter is. I have to use the letter given to me in the question, right? So I'm going to relate two of them. So I'm going to use k, which is sine k, because I have sine k already as 90, and I have small letter k as. So basically what I'm giving, I have capital letter K given to me as 90 degrees, and I have small letter k given to me as 22 kilometers. Then I want to use this k to look for this j, because this j is the angle I don't know. So I already have small letter j already as 8. So I have that my small letter j is 8 kilometers, and my capital letter j is what I don't know. Let's say sine theta or sine j. Let's say sine j is what I don't know. So I'm going to relate these two together using the sine rule. So I'm going to say that j over, I'm looking for the angle. So I'm going to have the first one on top. So sine j over j is equal to sine k all over k. And sine j here is what I don't know. So I'm going to have sine j over small letter j there is 8. And that's equal to sine k is sine 90. I have capital letter K as 90, so I'm using sine 90 degrees all over small letter k is 22. So I have 22 here. So when you cross multiply, this multiplies. So I have 22 sine j is equal to 8 sine 90 degrees. Now if I divide both sides here by 22, this cancels out this, so I have that sine j should be equal to, now notice that sine 90 is 1, so 8 times 1 is 8, so I have 8 over 22. So I have that sine j should be equal to 0.3636. So to find the value of j, I just find the inverse of sine j. It means that the arc sine of j is 0.3636 should be approximately equal to 21 degrees. That means the angle I'm looking for in this position is 21 degrees. So to find the small angle found here, I just add 25 plus 21, subtract from 90, and I get what's left over here. So I have that 90 degrees minus 25 plus 21 degrees. That's giving me, it implies that I will have 90 minus, this is 46. When you subtract this, you have 44 degrees, which means the little angle I have here is 44. So the bearing of T from J, the bearing, which is the second part now, of T from J should be, I'm adding in a clockwise direction, so 90, 90, and 44. So I have 90 degrees plus 90 degrees plus 44 degrees. So this is 180 plus 44, that's a 224 degrees. So basically we've answered question 1. So if you answered this correctly, you have a full mark. And for question 2, we are told that given that sine theta is 5 over 6 plus x and tan theta is 5 over 12, where 0 is less than x and x is less than 90 degrees, we have to find the value of x. Now you must know something, that since the x is between 0 and 90, it should be a positive integer that you are looking for. That is, the value of x lies between 0 and 90, right? So we are looking for a positive value of x. So for question B, I'm told that sine theta, I wasn't given the angle, sine theta is given as 5 over 6 plus x, 5 over 6 plus x, and tan theta is also given as 5 over 12. Alright, so I'm asked to find the value of, okay, they said given that 0 degree is less than x and x is less than 90 degrees, and to find x. Okay, now for this question, there are two ways of going about it, but I love going about it the long way, that is showing them my full workings. It shows that you know what you are doing. So since I'm seeing trigonometric ratios here, trigonometric ratios will work for only triangles, right? So I'm going to draw a triangle and analyze it. So I'm going to have a triangle, a right angle triangle, rather. This is my right angle triangle. Now you know every right angle triangle has 3 sides: opposite, hypotenuse, and adjacent. So it has an angle of 90 degrees. So the question should be, since they gave me an angle unknown here, I can place my angle any point. Let's say I put it here. So this is my angle theta, right? And this angle theta, this should also be the opposite. This should be the hypotenuse, and this should be the adjacent. But assuming I place my angle up here, I'm going to get the same thing. I'm going to go around it another way. Assuming I place this angle up here, this point will be my opposite, this will be my hypotenuse, and this point will be my adjacent. So basically the opposite is where the angle is facing. So if this angle here is facing this position, here will be your opposite. But assuming I place the angle here is facing down here, that means here will be your opposite as well. So how am I going to work with this? Remember that they said that sine theta is 5 over 6 plus x. Now let's recall that sine theta is opposite over hypotenuse, right? And tan theta, or let's say recall, okay, and then tan theta is opposite over adjacent. So what do you notice? Both of them have O as the numerator, right? That means for this one, this is the opposite and this is also the opposite. So I'm going to place 5 on the opposite direction. Okay, then for sine is hypotenuse, and the hypotenuse here is 6 plus x. Okay, so I'm going to place my 6 plus x on the hypotenuse. Then my adjacent is going to be for tan, right? And then my tan here should be 12. So I'm going to place my 12 right here. So to find the value of x, I will recall that using Pythagoras theorem, it says that c squared is equal to a squared plus b squared, and in this case my c squared is the hypotenuse, which is 6 plus x. So I'm having 6 plus x raised to the power 2 is equal to 5 squared plus 12 squared. So if I expand this guy, this will be 6 plus x, and then 6 plus x as well, and this will be 25 plus 144. So if I expand this guy, I'm going to say 6 times 6 giving me 36, 6 times x giving me plus 6x, x times 6 giving me 6x, and x times x giving me plus x squared. So I have this equal to 24. So if I add these two together, I should have about 169. Okay, that's correct. So if I should other like terms here, I have that x squared. I have that x squared plus 12x will be equal to 169 minus 36. So I have that x squared plus 12x will be equal to 133. Okay, so I'm going to go about this using the this is actually quadratic in nature. I can solve this using any of the methods, but I want to go with the quadratic formula, which states that I'll say using minus b plus or minus square root of b squared minus 4ac all over 2a. So this is a quadratic formula. I'm going to make use of this, right? Okay, so where b is a 12, then a is 1, then my c is 133, right? So I'm going to make use of this. So from that equation, I have that x squared plus 12x is equal to 133. If I make it to be equal to 0, I'll carry this inside, so I have that x squared plus 12x minus 133 equals 0. So I'm going to arrange these guys now into this formula. So anywhere I see b here, I'm putting 12. Anywhere I see a, I'm putting 1. Anywhere I see c, I'm putting 133. So let's go. So I'm going to have minus open bracket 12, which is b, plus or minus square root of b is 12 squared minus 4 into a is 1, then c given to me there is a minus 33. Sorry, there's a negative there because the 133 owns the sign, so I'm having minus 133, and all over 2a, that's 2 times 1. So I have, when this multiplies, I have minus 12 plus or minus square root of 12 squared is 144, then minus giving me plus. So 131 times 1 is 131, and 131 times 4 is 532 all over 2. So it implies that I have minus 12 plus or minus square root of, when you add these two together, you have 676 all over 2. Okay, so this is actually a perfect square. So working for that, I have that minus 12 plus or minus the perfect square of this is 26 all over 2. So it means that minus 12 plus 26 over 2, or minus 12 minus 26 over 2. So if I solve for this guy, this is basically minus 12 plus 26. That's going to give me, if you subtract 12 from 26 minus 12, this is giving me 14, right? So 14 divided by 2 is giving me 7 again. Or if you do minus 12 minus 26, that's a minus 2 plus 1 is 3. This is minus 38 over 2. That's giving me a minus 19. So basically I'm having a minus 19 in this place. But remember, we are asked to find the positive value of s. We have to recall that 0 degree is less than x and x is less than 90 degree. That means x is positive, right? X should be a positive integer. Okay, so our value here, we are going to pick the positive integer, which is 7. It means that x is just 7. Thank you for watching, and see you at the next one.